which he will talk about in greater detail in just a moment. So with that, Alex, you have the floor, and we look forward to hearing your presentation. It should still be sharing too. So yeah, your screen share.
So thank you for the introduction and inviting me here. I'm a software developer working a lot with different researchers. And today I want to talk about the challenges when working with researchers from different disciplines and how we can overcome them. But first, a little background information. So I'm the lead developer of OpenAtlas. I'm working at the acdh-ch, and I like to work with open source and scientific projects. So I quite enjoy my work I'm doing. And on the image, this was taken at a workshop from the Indigo project. And this project is about graffiti in Vienna. So my work can be quite colorful at times. And now shortly about OpenAtlas. OpenAtlas is an open source software. It was initiated about 10 years ago by Stefan Eichert and is still actively developed. It's a tool to acquire, structure, and manage research data. So because we want to structure data, the model is a very important aspect. And for that, we are using the CDOC-CRM, which is an international specification how to structure research data. OpenAtlas is used mostly by historical, archaeological, and prosopographic projects, like, for example, the Mammoth project. Now, to get a little feeling for the audience, I have 3 questions for you. I would kindly ask you to raise your hand if you ever heard about OpenAtlas before. Oh, okay, thank you, quite a lot. Next, I would like to ask you if you have ever used OpenAtlas, be it in a project or just testing the demo version. If you could please raise your hand. Oh, also some, okay, thank you. And last question. If you ever had worked with software developers together. Okay, also a few. Thank you. And sorry for the, we even have the online hand signs. Thank you too. Okay, let's jump right into it. So typical starting situation is, oh, I have to stand still more. A typical starting situation is we have an idea for a research project, we have our research questions, and we have available sources that we want to use. So basically, if a project decides to use OpenAtlas, it's an open source software, so you could download it, use it. You don't even have to talk to us. This is quite fine. But there may be some need for support. That's why we at the acdh-ch offer cooperations, which can include services like providing all the technical infrastructure. We can support with data modeling. And then there, of course, is software development, because there is already a lot of functionality in OpenAtlas, but with every project, there is something new we can implement. And near the end of the project, we can develop a presentation site so that the research results can be available for a broader audience. And we can also provide long-time archiving so that we can keep the research data for future generations. Also, you can see on this slide a few projects that are already using OpenAtlas, and maybe you recognize some of them. Now about the challenges. So we have people working together coming from different knowledge domains. They may use different terminology and have different concepts. And so sometimes you may have made this experience if you are talking to other people about the things you are working on. You maybe get blank stares. And but even more trickier is sometimes we think we understand each other, but have quite different concepts in mind. So this can be quite a challenge, a source of misunderstandings. The next challenge would be we have ever-changing requirements. So in a research project, when we begin to dive into our sources and try to structure the data, we get new insights. And these new insights might drastically change the requirements we had at the beginning. And this is perfectly fine because it's in the nature of research projects. If we would know everything at the beginning, we wouldn't need a research project in the first place. Also, these projects typically go over a few years, and this in combination with changing requirements and possible misunderstanding makes them difficult to plan. Not only the research project, but also the software. So I think it's very important that we are aware of these challenges. We can't prevent them, but if we don't take care, we may end up in a situation that at the end of the project, when we already invested a lot of time and resources, we maybe realize that it's not working how we imagined. It's kind of unfinished, like the snowman in the picture. And this can be the source of a lot of frustration for everyone involved. So also we have these challenges. With OpenAtlas, we had quite a good experience with our corporations. And that's because there are strategies to deal with these challenges. And these strategies involve mainly planning, and we're making a lot of use of something called feedback loops. And of course, communication plays an important role so that we can have a close cooperation. So more details on that. So about planning and feedback loops. So planning is important. We always try to plan ahead, but we have to expect the unexpected. What do I mean with this? To give an example, at the beginning of a cooperation or shortly before, I'm often asked to make a feature list, to list what we will develop for our cooperations. And I always answer, we can do this a little bit. So we look at a new project and maybe identify in the beginning some things we say, okay, we will need this and this, but we know that there will be more features in the course of the project, but we don't know which features this will be. So to say, we just have to leave room for these unknown features. We also plan on different levels. So there is long-term planning. So for example, we have a project that goes for 3 years. So the first year would be about acquiring the sources, making the users familiar with the software, implementing some features that are essential for this specific project. And in the second year, it's mostly about entering the data, structuring it. And in the third year, we may say, okay, let's look at the data in more detail, maybe do some restructuring and developing a presentation site. But we also have the short-term planning. This is in much more detail. So in OpenAtlas, we are trying to identify features new functionality. And we try to keep them small. So one feature shouldn't take more than, let's say, 20 work hours. If it's a really big feature, we try to split it up in smaller chunks. And then we take a few of these features and we say, okay, in about a month, we release a new software version. And we plan this about 3 months ahead. But this is already on a very detailed level. We say, okay, next month we do this, and so on. This is very helpful because it's important to show and discuss the progress we make regularly. This is then something we call a feedback loop. So let's say we develop some features and then we say after 1 month, okay, this is our new functionality. And then the user can look at it, use it, and then they may say, oh, that's great, that's exactly what we wanted. Or they say, this is somehow what we wanted, but it's not very usable, it's very cumbersome. Or they may say, what is this? I meant something completely different. And this is okay, as long as we notice it very quickly. So with these feedback loops, we produce something, show something, get used, we get feedback, we try to improve it. We can be very flexible and adapt our planning when needed. But there may be problems, not only what we want to produce, there may also be a problem with, for example, the timeline. So let's say we are in the 2nd year of the project and we realize we don't even have things we wanted to do in the 1st year. And this can have a lot of reasons. So for example, key persons may leave the team, or we have something like a pandemic, which can be very challenging on multiple levels. So of course we try to prevent the situation, but if we are in this situation, it's much better to know it before, because like I said in the beginning, we want to avoid a situation where we have at the end nothing finished and a big construction site, nothing works as expected. So when we notice this much earlier, we can react and we can, for example, prioritize and say, okay, we won't manage to do all the things that we wanted, but we leave away these not so important points. Maybe we can do it later, but at least we get the most important stuff done. Next, I will talk about communications. There are many forms. So we have direct communication like meetings, email, and chat. But there is also a lot of indirect communication that I think important too, because everyone who is interested should be able to have accessible information about the things that are interesting. So for example, we have our project website where you can find out more about the projects that are using OpenAtlas, the team, our events. There is a user manual. We have a public called issue tracker. So that is where you can see which features are planned in the near future. And also everyone can make a bug report or request a new feature. There's a lot of technical documentation, like how to install software. We have a demo and we also have a development demo version. This again is for short feedback loops. So we often show features that are not finished, but are in development, and people can try out these and can give feedback even as they are developed. And of course, we have the software releases. This is also a kind of feedback, so people see, okay, this and this is done. This maybe was postponed, and it helps a lot with our feedback loops. So how I'm with the time?
That's right, 10 10 more minutes. I have to do.
Great.
Okay.
I have a separate slide just about meetings. So I'm not a communication expert. I'm a software developer, and this is based on my personal experience. But a few weeks ago, I was joining some colleagues after work, and when I joined them, they were talking about meetings, and everybody complained, yeah, we have so much meetings and we would like to do more work. And I kind of agreed. But then I was a little bit surprised because it turned out they thought that most of the meetings were completely unnecessary. And I had two big realizations. One is that I'm extremely lucky because I don't think that about my meetings. And also I realized the meetings they have are mostly necessary. They are just very ineffective. And I interviewed them to find out what's going on there, why the difference. And I identified a few things that can make a meeting much more productive. So generally it's preferable in person, but of course this is not always possible. Also, structure can be very helpful. So that the meeting has a clear purpose and it is used to come to decisions. And the structure is also important that you can organize it to speak at first about the important stuff. So when the time runs out, you already have discussed these. Then also moderation can be very helpful. So sometimes you need someone to shut down a person like me who likes to talk. And it's great if it can be done respectful and friendly way. But yeah, sometimes you just have to move on in meetings. And also documentation. So in OpenAtlas, we are a very public project. So we have our meetings protocols public. Everybody can look at them. And we have them before the meeting so that people, I don't know, can prepare if they want to. They maybe can add their own topics and say, hey, we should talk about this too. And also, and this I think is not much used enough, but people can look at it and can decide for themselves if they are needed in this meeting, if they are even interested, and can really decide themselves if this meeting is necessary for them or not. Also, we update then the meeting protocol about the decisions we have made. And this is something a lot of people told me problems in their meetings is that they are discussing the same things again and again. And this is a good tool to prevent this. And also I like personally sometimes before a meeting to look at the protocol from the last meeting just to get into the thinking mode again about this specific project. So I'm thinking meetings are important. These are important for, like I said, communication, deal with misunderstandings, but they are very time intensive and we should use this time wisely. At the end, I would like to give a few tips when working with software developers. So if it's not already there, I would say you should insist on regular updates and visible progress. I'm very aware that some people don't like to show their work in progress, but it really helps to find these misunderstandings, see the problems very early, and then we can deal with it. But yeah, if we realize it at the end, like I said, it can be the source of a lot of frustration. Also try working together to plan together, find solutions together, prioritize together. We don't have to know exactly the sciences behind the other people, but it's good that we all have the same greater picture when working together. Okay, concluding, I invite you to take the chance to have a talk active software developer in front of you, ask questions, give feedback, not only now, but also later if you see me hanging around at the Congress. And yeah, thank you for listening.
Yes, so Alex, thank you very much for that presentation. If I could have you go to the previous slide quickly, then we'll go with questions. This is my personal tip in working with software developers. Make sure you wear a t-shirt and not a collar. But I'm sure there are more serious questions from the audience. Perhaps, here and then, yes.
Yeah, thanks for your presentation. It was really interesting. Can you tell me more about the work that you actually do with maths? So what your tasks involve?
Okay, so with the question is what our task in OpenAtlas involves?
Yeah, how do you, what do you bring to the math project? What do you do with it?
Okay, so basically, often, especially in historical projects, photographic projects, we have a lot of written sources. And the aim is to get this information, so to say, out of the sources and into a structured way. So basically, you try to identify small items in your sources, like persons, events, places, and structure them in a way that you can form a kind of a network. And with that, it's then much easier to ask research questions, make analysis like, I don't know, social network analysis, or use the data for something completely different, like a map-based presentation. The thing is, like I said, we are using the CDOC CRM. It's a very good system, but it's a little bit complex, so to say. So this is a specification that basically says there are entities like an actor, a place, an event, and they define properties to connect them, to build this structure. But it's hard for people that are not so knowledgeable in the system to use it. So what we are doing is we are building a web interface where you don't have to know about the underlying model. You have these typical forms with, yeah, it has a person, it has a name, it has a birth date, and maybe a residence and so. And so you are doing the connections in a user-friendly way that you don't have to be aware about all the stuff that is going below there. I hope this kind of answers your question.
Yeah.
Maybe if I could just jump in really fast, and then we'll get to Andreas Ruby's question. One thing that is difficult with the Athlon material is and we talk about this a lot in the project actually, is the question of names. Because we have names in different languages and different forms, and there are different transliteration systems. And one feature we asked for relatively early on, I think it's included in other projects too, was that if we could just have, say, 10 names associated with one person in Greek and Georgian, the different forms you might find in the sources. And I think, that's a big advantage of using a database like OpenAtlas to be able to search. You can search for any of the forms of the name, as opposed to a standard graphical dictionary where you might have to look for Michael, or you might have to look for the person's monastic name. And that's just one area where we had to sort of adapt the database a little bit to project specific needs. But yes, Andreas.
Yeah, thank you very much for your presentation. You mentioned it very briefly, the question of sustainability, and I can easily imagine that many scholars are still concerned about using a platform like OpenAtlas or others, because they are not sure that the data will be secured in 10 years from now, or even for the next generation of scholars. So I can easily imagine that scholars very often put this question and approach you with this question of sustainability. So if you could just summarize your thoughts about it, that would be really grateful.
So the question is about sustainability of data, and it's a very good one. So basically, like an OpenAtlas, for example, when users are putting their data in the web interface and say, okay, this person has this name and this birthday, and in the end, it's stored in a database. And we don't know if this kind of database still will exist in 20 or 30 years. So on the one hand, we have to preserve the data so that it still exists and didn't get deleted or something. But also, and this is an important point, we want the data in a form that we can be relatively sure that we can still use it. So for example, if you now find an old disk from, I don't know, the 80s, it may be problematic to even read the disk. And even if you can read the disk, the programs are not existing anymore for a long time. So this can really be a challenge. That's why, and we don't do this in the OpenAtlas team, but at the institute I'm working, they're offering long-time archiving to cover both points. So they say, okay, we have safe places where we can store the data and there are multiple backups and so on. But they also, and this is can be a cumbersome process, but it's worth it. They try to save it in a format that can be read even in 50 years or so. So basically it breaks down, I simplify it a lot at the moment, but to make simple text files and store the data in this way, so that you don't need a complicated program like a database server or so. And of course, we have no idea what will be in 50 years, but they put a lot of thought into it, how to preserve this data in a way that it will be readable in the future. Basically, it boils down to not use very complex programs, not use programs that are commercial. Because if it's open source, there is a chance that even if the company doesn't exist, we can still use stuff. But if it's a company and it takes its asset into the grave, so to say, there is not much you can do about it. But yeah, basically keep it simple, keep it open. And these are the strategies to use when talking about long-time archiving.
Further questions from the in-person audience or perhaps online as well?
I'm not seeing.
You can also, by the way, I think it's okay if you want to ask quite short questions to be directed at both presenters too, if you would like, with the project in general, since we have, seems like we have a little bit of information. Yes.
Do you work with maps? Do you incorporate biographical information only textbooks?
No, it's the question was if we only process text-based information or others as well. So, for example, there is an interactive map integrated into the system. So you can also note down graphical information, like location of places. You can also connect this relatively easy with other systems like GeoNames, which is a collection of many places. And you can say, okay, I mean, for example, Leeds. And in the other system, there is a leads to, and you can take over their identifier, their geographical information, so you don't have to draw everything yourself. And yes, so that's possible too.
Just to jump in as well here, for the MEMS project, we're primarily interested in people, but we also, if places are associated with the prosopographical entries, we also put them in the database and connect them to geonames or to Wikidata. And sometimes, and that's sort of a neat feature with OpenAtlas, it's something I haven't really used in detail yet, but in the Aphnite documents, a lot of times there will be place names where we don't know where this place actually is. So we know it's on Mount Athos, or we know it's in Cassandra Peninsula or something like that. And you can actually draw within OpenAtlas, like a circle or a boundary of where you think the place was, which is, yeah, it's a neat feature. It's not something that we really use so much because we're primarily interested in prosopography, but it is a resource in OpenAtlas.
Yeah, this touches a very important point, uncertainty. You have this in time, you have this in places. And with historical projects, you have this very often. How do we deal with uncertainty? And in OpenAtlas, we solved it like, let's talk about a place. You can make set a point, like in Google Maps, and say, okay, it's there. That's the simplest version. Or you can draw an area and say, oh, I know exactly that we have the plans of the ruins, and you can draw the exact structure. Or if you don't know, you can draw also an area. But the trick is you have to draw it big enough so that you are certain that this place is inside of it. Because it would be very difficult to deal software-like with information like it's there maybe or relatively certain. And that way, we don't have to deal with this, which are more of human categories to think. And so it's relatively simply, we say, okay, you have drawn an area that is big enough so that you are absolutely certain. And if you are very uncertain, it has to be a big blob or all over Europe or whatever. And it's the same principle of time. So in OpenAtlas, you can say, okay, I have the exact birth date. More often, interestingly, it's the death date that it's known, not the birth date. So yeah, you can enter that. But if you are not sure, you can choose a time frame and say, okay, between this and this year, something like this. But again, the trick is to choose a time span that is big enough that you are absolutely certain it's inside of it.